So hello, good evening. It's 7:15 already, and you're welcome to Open Source Nest Code workshop. So I'm going to be introducing our instructor. Our instructor is here with us. That's Chukwuebuka Michael Ezeokeke. You're welcome, sir. A little bit about him. He's an ML AI engineer or researcher. Like it's he's into machine learning and artificial intelligence. So he has experience using Python, AWS, machine learning, deep learning, and so on and so forth. So he's going to be taking us into the world of machine learning and artificial intelligence. So help me welcome Mr. Chukwuebuka. Hope I'm not murdering this name. Yeah, welcome. Yeah, I need more reactions. You guys should react too. Let's react. Let's react. Let's react. Let's react. So you're welcome. You have the floor.
Okay, yeah. So good evening, everyone. Good day, everyone. I will share my screen. So basically, the topic for today is, or let's say, the goal for today is how to building an opus and building your first ML project and putting it on open source. So the first thing is in machine learning, right? Just one thing you need to know, like you have traditional machine learning and then you have deep learning, you have generative AI. So this session, I'm just going to talk more about traditional machine learning, which deals with you working with tabular data sets and then building your models. So in this case, there's going to be a classification model. Okay, yeah. So basically, just this is the repo. So in this case, the goal of this task was building a machine learning project aimed at predicting customer churn for an internet service provider. So the model should be able to identify customers who are likely to leave the service and should enable the ISP to implement targeted retention strategies. So this project involved data processing, exploratory data analysis, also known as EDA, feature engineering, model training and evaluations. And then there are two models which were developed, which is the logistic regression model and the XGBoost model. And both of these models were saved as a serialized object.sav files for deployment purpose. So I'll just go to the first thing, which is the model Jupyter notebook. Okay, it's really up. So yeah, this is the model Jupyter notebook. So the first thing you do, you need to know the libraries, the Python libraries that you need to work with. So this first line of code are the Python libraries I'm working with. So Pandas is a Python library for data processing. NumPy is a Python library that is used for numerical calculations and numerical processing. Then CBOM, Matplotlib, they are Python libraries for data visualization. And then datetime, if you're working with datetime in Python. So whenever you see anything related to sklearn in Python, it refers to a machine learning model. So sklearn is a Python package that deals with a lot of traditional machine learning models. So the models can range between classification models, regression models, supervised and unsupervised machine learning models. So in this first thing now, from sklearn.impute, simple imputer. So simple imputer is used in scenarios where your data set have missing values and you need to fix up those missing values using data processing methods. And then you have min max scaler, robust scaler, standard scaler. So these are strategies that are used to scale your data sets in order to have your data set values fall within an accepted range of mean values, minimum value, maximum values. Then you have your classification reports. So another thing in machine learning is we are training your models. You have to use train test split. So where train test split comes in is you have your data set. You have to split your data set. So there are different strategies to split your data set. You can use the 60, you can use the 80-20 strategy, that is splitting the data set into 80% training set, 20% test set. Or you can decide to include a validation set. So you can decide to use 60% to your training set, 20% to your validation set, 20% to your test set. So in order to split your data set, you use train test split, which is from sklearn.model selection. And then you have linear model. So this is a logistic regression, and then this is an SVM. SVM is another traditional machine learning model. So we have decision tree classifier, and so when we are talking about tree-based models in Python, we have decision tree classifier, you have random forest classifier, gradient boosting classifier, and ADA boost classifier, and then you have the XGBoost. So basically, you have to just import, know the libraries you're going to work with. So once you're done importing them, you now have to load your data set. So your data set could be in an Excel file format or a CSV format. So in this case now, the data set which I was working with, cell to cell train.csv, is in a CSV format. So since it's in a CSV format, I have to read this data set into a pandas data frame using .read_CSV. So another thing, whenever you see PD in a Jupyter notebook or in a Python file or Python script, in most cases, let me just say 95% of most cases, it refers to pandas, because here you can see it import pandas as PD. So yeah, I'm just going to create a variable called data and assign this data sets to this variable. So now these are the dictionaries. So when I'm talking about data dictionary, it just means the brief description of each columns of that data set. So if someone was to come to the Jupyter notebook and goes through this data dictionary, the individual will be able to understand that, yeah, when you look at customer ID, that means customer ID, which is a column of this data set, is a unique identifier for each customer. And then you have the churn column, which is just a binary indicator of whether a customer churned. So when you say binary indicator, it just has two possible values, yes or no. And then you have the monthly revenue, monthly minutes, total recurring charge. So these are just the columns of this data set. So once you're done writing out your data dictionary, you move to the next stage. You want to know how many rows and columns are found in your data sets. And in order to do that, you use the pandas dot shape statement. So with dot shape, you can be able to identify rows and columns. So from here now, you can see that this data set has 51,047 rows and 58 columns. Now, if you want to view the first 5 rows of your data set, you just use the .head statement. And another important thing to know is that in Python, it doesn't start counting from 1, it counts from 0. So that's why you're seeing, like, when I run data.head, the first output you're seeing here, the index is index 0, not 1. So you just need to know this, that Python doesn't count from 1, it counts from 0. So moving on from that, let's now look at a column called credit rating. So credit rating, now we want to implement some element of data processing to this column. So in this case, now we can just use the .string.split to process this column and then get the unique values from the column. So now, once you're done processing the column, to get the unique value, just use the .unique statement, and you can see the unique values from this credit rating column and highest, medium, good, very low, high, low, lowest. So once you're done with that, I just did this again, so I'll be sure what I'm working on. Now, if someone asks you, how can I just get a list of all the columns in the data set you're working with? If you don't want to use data.head, because in some cases like this where this data set is actually large, if you use data.head, you might not be able to see all the columns of the data set at once. In order to get a, let's say, brief overview of all the columns related to your data set at once, you have to use the .columns statement. So using data.columns now, you can now have a clear overview of all the columns associated with your data set. So you can see this now, these are all the columns associated with this data set. And these columns are what I wrote out here as part of the data dictionary. So you're moving away from this now. If you want to have like a brief info of your data set, you can use the .info statement. So with .info statement, which is associated with pandas, you can see that when you run this, it shows you 51,047 entries, which is just 51,047 rows, and it gives your total number of columns. So I see here total number of columns, 58 columns, and then it also gives you the data type of each columns that you have. So you can see in this situation here, I can see that customer ID, the data type is an int. Then for John, the data type is an object, which is correct. So in there are some scenarios, because let's be honest, to be honest, real world data set is not always neat. It's not always tidy. So in most cases it's dirty, so you have to clean it. So when you're working with some real world data sets, the data type for a column, the data type that was initially assigned to a column in that data set might be wrong. So that's where you use dot info statement from pandas to know, to be able to see the data type that was associated with that column. And once you're able to see this data type, you can now view the column and be sure. Because some people might say that, let's say for example, someone might put age, the age column of a data set, and assign an integer value to as the data type for that column, for that age column. But when you now access the age column, what you're seeing there is values like, instead of the number 30, you're now seeing 30 written in strings, that is in text format. So in this case now, you now have to do what's called data processing. So you either change the data type of that column from integer to just string, or you change every single value in that column from strings to integer values. So .info helps a lot to know the data types associated with every column in a data set. So moving from this, now you want to know which columns of your data set have missing values, because like I said, real world data sets are not always neat and tidy. They are some, in some cases they are off. So here now, if you want to know which columns have missing values, you just use the .isNull.sum. So when you run this now, you can see that the customer ID, it returns zero. That means there are no missing values. John returns zero. There are no missing values. But you can see that here now, monthly revenue, we are seeing 156, monthly minutes 156. So all this means that these columns here have missing values in the data set. So that is, in this data set now, these columns have rows which are missing. And if you are not informed that some columns of your data set have missing values, I just went straight to building your machine learning model. Let me be honest with you, you're just going to build garbage in, garbage out. You're going to build trash, and you might be proud of yourself saying, I built a machine learning project, and you will post it online, and you may kind of a way, you may kind of lie that you built an LLM from scratch. But be warned, if I see such, I'll drag you. So let's just proceed from there. Now we have what is called categorical columns. Now you have your data set. You want to identify which columns of your data set is falls within the categorical data types. So then, in order to do that, you use the select underscore d types. You just select data types and you include the data types which you're interested in. So in this case now, I was interested in object and category columns. And now, once you run this code now, you can see that these are the columns of this data set which falls within categorical data types. So these are just there. And then you replicate the same for numerical columns. Now you might ask, why do you want to know which columns falls within categorical and numerical data types? Now the reason is very important, because if you have a knowledge of your data set columns that falls within categorical and numerical type, you know which columns you need to focus on and carry out some operations. So let's say you have a data set, a column that is categorical. You cannot just go and use simple imputer and then fill in missing values by mean when the text, when that data type is categorical and the data in those columns actually text data. So in some cases that should not work. So that's why it's important to know which columns are associated, like which data type categories are associated with your columns in your data set. So once you have identified your categorical columns and numerical columns, just you now implement a simple imputer, like I said earlier, is used to fill up missing values. So you can see here now, I just created a variable called imputer numeric. So I'm going to use simple imputer strategy media to fill up missing values in my numerical columns. So you can see that if I was not, if I didn't have any knowledge of which columns are actual numerical columns, and I just applied simple imputer to the data set, for some columns for some columns now, I'm going to get an error back. So now that I was able to know which columns of my data set are numerical columns, I just fill in this variable here. So data numerical columns, the simple imputer fit transform numerical columns. And once I run this again, you can see that now for every single missing values that falls within the numerical column, they have all been cleaned out. And now what I have left here is service area. And this service area now is not a numerical You didn't fall under numerical column, you fell under categorical column. And simple imputer strategy medium won't work for it because it's not an integer or a number data type, it's a string, a text data type. So moving on from this now, you can, yeah, another thing in another part of pandas is we have the dot describe. So the describe is used to show you summary statistics or summary descriptive statistics of your data set. So it's going to display the counts, the mean, the standard deviation, the minimum value, the 25 percentile, 50th percentile, 75th percentile, and the maximum value of each columns in your data set. So you can, if I look into this data set now, I can see that my count ID has 51,047 rows, and that applies for all the columns here. And I can see the, let's say the minimum value in this count ID is this, the maximum value is this. If I look at monthly revenue, what is the minimum value in monthly revenue column? It's minus 6.17. What is the maximum value? 1,222.38. So this is just replicate, we just replicate the same for each columns if you want to know what are the minimum and maximum value in a column. So now once you're done with that, you need to know another thing you need to know is that are there duplicate values in your data set? Like I said, data sets are not neat and tidy. In order to do that, you use the dot duplicated dot sum to know if there are duplicate values in your data set. So once around this, it returns 0, which means there are no duplicate values in your data set. And now the next thing I decided to focus on was outliers. So my focus were on the numerical columns and reasons that they fall under numerical data types, and I wanted to analyze if there are outliers in each of these numerical columns. So I just use this four statement, and then after I run this now, you can see. Let me just explain it one of this now. So yes, let's say this. Okay, yeah, just looking at this now, monthly revenue. So basically, when you use a box plot helps a lot to identify outliers in a column of your data set. So if you go through these numerical columns and all these box plots that was created, you can see that there are outliers here. Now, in some cases, a box plot is just going to give you a graphical overview of your outliers, but it won't help. It might not help a lot. Let me not say it won't. It might not help a lot to remove those outliers. So now how do you do this? You use what is called outlier threshold and implement interquartile range. So I just created a function called an outlier threshold, and then implemented my Q1, Q3, which is my first quartile and my third quartile. Then my interquartile range is Q2 minus Q1, and I have my lower limits. So this is like basic statistics and mathematics related concepts. So once I implemented all this now in my function and I run this now, I can see that my customer ID now, this is lower limit and this is the upper limit, my customer ID. And this applies to all numerical columns here. So now I want to check if a variable in the data frame, does it contain outliers? Yes or no. So there's another function called check underscore outliers. So I have my lower limit already, I have my upper limit, and then outlier threshold. And once I run this now, customer ID, does it have outliers? It returns false. Now monthly revenue, does it have outliers? So you can see the value of the outlier 3009. Monthly revenue true, it has outliers. Monthly minutes, you can see the values of the outlier and return true. So basically, this function was just a function I created to be able to know if each columns of these data sets have an outlier. So this is what it returned. Now that I've been able to identify my outlier, and I created another function called suppress outlier. So this function is just used to remove any presence of outliers based on the lower limit and the upper limit. So I just run this function and you can see the suppressed outliers. So here we have monthly revenue 2009 and this suppressed outliers for this column. And once I was done with it, and I created another for loop to check if there are still outliers in the data set. Now there's a reason why I created this for loop again. It's like a validation. So in some cases, maybe the function that I created, let me just say some of the columns were kind of skipped out of the function. So I don't want to leave anything to chance. So I just have to create this for loop to be sure that there are no longer outliers in this data set. So with this for loop now, you can see that when I run it again, for each of these columns which had outliers previously, it returned false. So you can see that now there are no longer outliers in the data set. Now you might ask, why do I want to remove outliers from this data set? So yeah, if I allow a column of my data set to be filled up with unnecessary outliers and a huge presence of outliers, is going to affect the performance of the machine learning model I'm going to build, because my model could, in this case, might be biased and it's not going to tell the clear picture, the true picture of what I needed to do. So yeah, after I've dealt with my outliers now, I now implement what is called a local outlier factor. So local outlier factor is just a method for detecting outliers by examining the relationship between multiple variables in observation units. So to work with local outlier factor, just use this. So this is from wherever you see local outlier factor is from sklearn, which I said earlier on, is a Python library for machine learning related tasks. So yeah, with local outlier factor and you run this, you can see the output now where it got the number of neighbors and the scores for each of these neighbors, the scores associated with the neighbors. So this is just explanation of the code. I think just explanation. So yeah, moving on from that, and I wanted to know if there's a skewness. I wanted to know skewness and kurtosis. So now with skewness and kurtosis, just to provide insight into the shape of the data distribution. So this is like statistical tests. Not that some machine learning engineers don't implement skewness and kurtosis, but you can decide to implement it if you want. So moving from this now, the next thing is going to be, is there any presence of class imbalance? Yes. Now, in machine learning, your target feature. So in this case now, I'm building a machine learning model for customer churn, which is a classification task. So classification, wherever you hear about classification, it falls under supervised machine learning. In supervised machine learning, you have classification and regression. Classification machine learning deals with data sets that have labels, and then regression machine learning also deals with data sets that have labels. But in this case now, it's not like a binary based labels, it's more like a numerical based labels. Now, unsupervised machine learning deals with data sets that do not have a predefined labels. So here now, when I'm talking about classification, these data sets have predefined labels, which is the target column, churn versus no churn. That is yes or no. Now, I want to know if there's a class imbalance. If I didn't, if I let me just say I was not serious about identifying any issue of class imbalance in my data set, and I went straight to building my model, this is the funny scenario that might happen. After I build my model and I put in a new sample data into that model, the model might be predicting always that this customer is going to churn. This customer is always going to churn, or this customer is not going to churn. Now, there might not be good performance of the model, and one of the reasons is because I didn't fix class imbalance. And if you don't fix class imbalance in your data set, your model is always going to favor the majority class of that target feature or that target column, and it will ignore the minority class of that target column or target feature. So here now, after I run this code, so you can see that there's a huge gap between the no churn and the churn class labels of this target column. So you can see the difference here. No churn has like 36,336 counts. Then churn has 14,711 counts. So there's like a huge difference. So there's a huge difference of class imbalance. Now, how am I going to fix this now? To fix class imbalance, I have to implement some strategies. We can use encoding and the rest. So let's just move on from here now. So I've identified my class imbalance and I went straight to encoding my categorical columns. So I used the label encoder and I excluded the target column, which is the churn column. Now you might ask, why do you need and why am I implementing encoding? Why do I want to encode the categorical columns of my dataset? So basically, if I try to train a machine learning model and encode I don't encode columns that have text data types, string data types, the model, so let's say in this case now, let's say logistic regression model, it might, let me just say it will break because it doesn't understand those text data. And even if you are working on sentiment analysis and sentiment analysis that deals with text, huge corpus of text data, you still have to pass it through what is called vectorization, TF-IDF vectorization, count vectorization. You don't just feed those text data directly to your machine learning model. So in this case now, since it's just a task of classification machine learning, I just have to implement label encoding, which converts those text data to numerical format that the machine learning model can understand. So I'm going to use label encoder. There are different encoders. There's label encoder, there's one not encoder. And these are like two popular encoders. But in this case, I decided to use label encoder because I'm just interested in two features, 0, 1, yes or no. So let's just move on. Moving on from this now. These are just how to create the label encoder and then encoding the chunk column. So when I encode the chunk column, remember initially the chunk column was just yes or no. So now that I encoded the chunk column, it's just going to be 0 or 1 in the chunk column. So moving on from this, next thing now is I want to analyze if there's a correlation between the target variable and numeric variable. So I already know that the chunk column is a target variable, and I already have my numerical columns. So just creating these 4 statements and then a dictionary to study their correlations. When I run this code, what is the correlation between churn and customer ID? Is a negative correlation. What is the correlation between churn and monthly revenue? Negative. And then what's the correlation between churn and average minutes? You can see it's a positive correlation. So there are some correlations here that are negative and there are some that are positive. So this helps a lot to know which columns are going to actually matter to your target column in this data set. So this is just a data visualization, a plot of the correlation between the target and numeric variables of data set. And then now let's see this now. Yeah, I want to group my columns into logical categories. So now this falls within what we call feature engineering. So yeah, I'm grouping my columns. I have director assisted course, average mean improvement course. I just group this now into a list called core behavior columns. And yeah, anything that deals with revenue falls within revenue service columns. Anything that deals with customer characteristics, handset models, do you have credit card? These are just customer characteristics column. And then grouping and calculating the mean for core behavior metrics by the churn, then melting for Seaborn compatibility, and then plotting the core behavior metrics, grouping and plotting for revenue and service metrics, and then this just grouping and plotting for customer characteristics. So basically, this is the plot. The first plot now is a core behavior metric by churn. You can see that the churn column, because I implemented label encoder, it has changed from the initial values of yes or no to 0 or 1. So wherever you see 0, 0 means just going back up here again. 0 means no churn, 1 means churn. So here now you can see that 0. So now for this 0 value in for this 0 label in this churn column, you can see the core behavior metrics. And then for the churn column, customers that are going to churn, you can see the core behavior metrics. And then moving on now, you can see revenue and service metrics by churn. So you can see those customers that did not churn, what are the monthly revenues are you going to make? So you can see wherever this green label is attached to it. So this is monthly revenue, this is monthly minutes, total recurring charge, percentage minutes. And then moving on to the next metric, so customer characteristics by churn. So let's say customers that do not churn, and they have handsets. So wherever it's red label, these just the handset models, age, H11, do they have children and the rest. So these are just labels. So basically, these plots compare various metrics of customers who have churned and those who have not churned. So the first plot focus on core behavior. So this is just like a written description. Oh, sorry. Sorry, hold on. Okay, going back. So this is just like a written description. So basically, when you're working on machine learning tasks, some stakeholders might not understand the technical implementation behind what you're doing. So you have to write a brief description of what you did. So this is like a brief description of what this data visualization plots are meant for. So if anyone wants to read this now, can understand that okay, this is what this plot is meant for and the rest. Then moving on from this now, I wanted to know what are the monthly revenue by device characteristics. So this is just a new variable. And then grouping handsets web capable, refurbished, and then aggregating it by the main monthly revenue, the main total recurring charge, and the main current equipment date. So this is just this, and this is an explanation. So all this I'm doing here so far falls within, let's say, it falls within first thing, data preparation, data cleaning, exploratory data analysis, and feature engineering. So actually gone I've not actually gone towards building the machine learning model. What I'm doing is understanding the data set and how it is important, how it relates to the task at hand. So moving on from this, let's now go to building the machine learning model now. So yeah, building the machine learning model. An important observation when building a traditional ML for fraud prediction is that when it comes to understanding why customers might leave a service, you use traditional machine learning. So basically, this is just like a brief description. In churn analysis, there are far more customers who stay than those who leave. So this leads to what we call class imbalance. To address the method of class imbalance, you use smooth technique, synthetic minority oversampling technique, or you adjust the class weight. So if you're using models like random forest, you can be able to adjust the class weight if you're using a random forest algorithm. So this can help to balance your data set and give a fair view of both groups. And yeah, in machine learning, traditional machine learning, you have metrics, we have the accuracy, we have precision, we have F1 score, we have recall. Now, you need to know that in this case now, you need to look at a metric beyond just accuracy. Because if you look at how accurate your model is, it can be deceptive. And in churn prediction, the stakes are high. You need to look at more telling metrics like the area under curve and the F1 score. Now, the F1 score is also known as the harmonic mean between precision and recall of your model performance. Because these metrics are going to give a clear picture of how well the model performs across both churn and retained customers. And now moving on, let's now start implementing building the machine learning model. So these are the models. I have my ensemble model, which is a random forest classifier. For processing, I have label encoder. I have my robust scaler, I have my min max scaler. To get the reports for my model, after I've trained my model, I have classification reports, I have my confusion matrix. And to split my data set, I have my train test split. To implement hyperparameter tuning to my data set, I have randomizer series. So now in hyperparameter tuning, you have bridge start series, which I don't really recommend, but some people do use it. Bridge start series takes a lot of time before it finishes up your hyperparameter optimization. So yeah, after moving on from there, you now have column transformer, which is a transformer, which is like a pipeline. It's a pipeline that is used to build your machine learning model. And you have logistic regression model, and you have one of the best models so far, the SG Boost model. So yeah, since this is a classification model, I use the SG Boost classifier. It was a regression model. There's something called the SG Boost regressor. So yeah, I'm just getting back the column names of my data set. So I already know my target variable, which is the churn, and I know the features I'm going to exclude. So customer ID is not really needed. Service area is not needed because it's not a customer level feature. Receive calls is not needed. Referrals made by subscriber is a low priority feature for the goal of predicting churn. Now, the reason why I'm excluding some features and leaving some features is that if I train my model with all the features, like in this case now, when I'm talking about all the features, I'm talking about all the columns of my data sets. I stand a very good chance to build a machine learning model that's going to predict a lot of noise because there are features which are not really needed or relevant to this target column, the churn column, which I'm now going to include to my machine learning model, which is going to contribute to a lot of noise and it's going to affect the machine learning model performance. So because of that, I have to know the features I'm going to exclude and features I'm going to leave. So now these are features I excluded, and these are good predictor features. So these are features I am going to include to this model. So moving from this now, I just created a list called the features. These are just features I'm working with, and then getting the numerical columns. That is the data types of these features which I selected that falls under numerical columns. Now, once I've done this now, I'm going to create two variables, my X variable and Y variable. Now in my X variable, I'm going to drop my target feature or my target column, which is the chunk column. And then my Y variable, I'm going to include the chunk column. Now, once I'm done doing this, I can now implement train test split. So I'm splitting my data set into a test data set and a train data set. So I'm going to just use x underscore train, x underscore test, y underscore train, y underscore test. So these four variables you're seeing here are going to include the training set of my x data set, the test set of my x data set, the training set of my y data set, the test set of my y data set. And with train test split, I'll be able to split this data set into training and test set. You can see now using train test splits, I included the x variable, the y variable, and here I say test underscore size equals to 0.2. And the reason why I say 0.2 is that in this case now my test data set is going to be 20%, my training data set is going to be 80%. Now I now included random underscore state equals to 42. So one of the reasons why we use the number 42 and we attach it to random underscore state is that 42 helps a lot in reproducibility. So if I train this model on my laptop, my Jupyter notebook, and someone else picks up this Jupyter notebook with the data set and train the model, we should be able to, let me not say 100%, but we should be able to get at least the same performance that I got initially. So this random underscore state got 42 helps a lot in reproducibility. So now I know the models, the machine learning models which I want to work with. I just include them in the dictionary. So you can see the random forest classifier model, the logistic regression model, and the XGBoost classifier model. Now I just want to specify here. Whenever you hear logistic regression model, please don't think it's a regression machine learning model, because funny enough, anyone can ask you this. Let's say we are going for a machine learning interview. Is a logistic regression algorithm, is it a regression model? And if you say yes, I'm sorry to say, but they will not take you serious again. Logistic regression is a classification model, not a regression model. So yeah, moving from this dictionary, and I implement what is called a scalar. Now, the reason why I need a scalar is that with the numerical values or the numerical columns of my data sets, of these selected features from the data set, I want to make sure that those numerical column values are scaled. They're within a range of minimum value and maximum value. I don't want anything that has too high range, too low range. I just want them to be within a range. So in order to do that, I use what is called a scalar. So you have your min max scalar. There are different scalar. There's a robust scalar. There are different types of scalar. There's robust scalar. There's standard scalar. But in this case, I decided to just use the min max scalar. So now just assigning the min max scalar to my scalar variable. And then to scale my train data set, I just use scale.fit underscore transform to scale the X train data set. And then to scale my text data set, I just use scalar.transform. So once I'm done with that, I already know my numerical features, and then I know the label encoded features, and I have my binary features. So moving from this, I scale numerical features, label encoded features, and I also scale numerical features and label encoded features of my test and train data sets, and then just convert both of them, the train scaled and test scaled, to a pandas data frame. So whenever I see pd.data frame, it means that you're converting whatever you have to a pandas data frame. And then I combine both the process features, including the binary features that don't need any transformation. So yeah, if you look at this now, this is my trained data set that has been processed, my X-trained data set that has been processed. And now I want to train and evaluate each model. In order to train and evaluate each model, I use what is called a pipeline. So a pipeline is just another feature that is attached to the sklearn library. So to work with it, from sklearn.pipeline import pipeline, you're using this for statement now. I have my model name, model in models, I have my pipeline, steps is classifier. I'm going to fit the model to my X train process and my Y train, and then I'll make a prediction on the test set, that's the test set of my X variable that's been processed, and then I'll evaluate the model. First, I'll evaluate the model using accuracy metrics, which is accuracy score, and then the classification report, and then I'll print the results. So the result I'm interested in here is the model, the accuracy, and classification report. So now after I run this now, so just remember there are three models: random forest, logistic regression, and XGBoost classifier. These are the models I included in my dictionary, my models dictionary. So if I run this for statement now, you can see the first model, random forest, the accuracy was this. You can look at the classification reports. So the precision, the recall, the F1 score, the weighted average, macro average. So these are like the metrics from the random forest. You can look at logistic regression. You can see the metrics from logistic regression. Yeah, now let's say random forest was able to get like the recall rate for the customers that did not churn to be 0.97. And then logistic regression said that it was 0.99, which is like 99%. So these are the metrics. And if you look at XGBoost classifier, XGBoost classifier said that this was 0.93. So now, there's just one thing to know. what I did initially, I just built these machine learning models. I did not fix class imbalance. I did not implement hyperparameter tuning or hyperparameter optimization. I just went straight to building the model because I wanted to get the initial metrics so that once I'm done building the model the first time, before I now go to the model performance tuning and the rest, I should be able to now compare changes in the model, let's say changes in the model performance. So this is just a first stage of building the model. Now that I've gotten the metrics I needed, I'm going to now apply what is called smooth to fix the issue of class imbalance. So now to fix the issue of class imbalance, I will include smooth now to my pipeline. The first time, what I just included was the machine learning model. I didn't include smooth. So including smooth to my pipeline now, I'll use it to fix the issue of class imbalance. And I will just implement the same thing, fitting my model, make prediction on the test set, evaluate the model, print the result. So now that I implemented smooth, you can see that the accuracy of random forest reduced to 0.6725. Initially, the accuracy of random forest was 0.7178. So you can see that even the record of random forest reduced to 0.90 from the initial 0.97. So you can see that these metrics for these models now kind of dropped. So this is like, these are the things that the technical details which are really important in machine learning. So if let's say a newbie or someone that just new to machine learning didn't know anything about class imbalance, fixing class imbalance, I just went straight to building the model. Person can just say, I built my machine learning model, and then now send it to the open source community and say, yes, I've built my model. This was my model performance. Now, people that have been in the field for a long time, they're like, okay, you have built your model. Can we see your Jupyter notebook? And they now see that you just went straight to doing this. And let's say they identified that there was class imbalance, and they went through your Jupyter notebook and they didn't see you fixing anything related to class imbalance. They just say you built your model. It's just, let me be honest with you, you did not build a good model. You just built what is a plug-in and play model, something that is just trash. So moving from there now that I applied smooth, you can see that with smooth, the metrics of the initial model kind of reduce. So I'm getting close to a clear performance, a clear picture of how these models were meant to perform from this data set. You can see even logistic regression accuracy dropped to 0.4969. But the initial metric of logistic regression, it said that accuracy was 0.7153. But since I applied smooth, it dropped to this. Even the record that was 0.99 dropped to 0.49. So even SGBoost dropped. Now, so the code above does the following. It just splits the data, it implements smooth within the pipeline. So now that I'm done with smooth optimization, smooth technique, and I go to the next stage, which is hyperparameter optimization. Now you might ask, why do I need hyperparameter optimization? Now with hyperparameter optimization, I can be able to get the best features to use and train the model furthermore. So now, in this case now, we look at this dictionary called models. So you have the random forest model. So when you see classifier, this is just the classifier. So now these are the parameters. So now this is just a random list of parameters in a list attached to this classifier and n estimators, max depth means sample split, sample sleeve. So now this is just for random forest, and the same again. Logistic regression. Logistic regression has its own parameters. So these are the parameters attached to logistic regression. You have the C, classifier underscore C, you have the penalty, you have the solver. And then for SGBoost, estimators, max depth, learning rate, subsample. So now I've gotten my dictionary now, and I'll use this now to train my machine learning model again in my pipeline. So in this pipeline is now going to include both smooth and it's going to include both smooth and the hyperparameter optimization technique, which is the randomized search sieving. So now moving from this now, you can see that the pipeline we have smooth. And since I'm implementing hyperparameter optimization, I have my randomized search sieving attached to this random underscore CV variable, which is going to include the pipeline, the parameter distributions, and then the scoring. I'm scoring based on F1 because, like I say, F1 score gives a good metrics. It gives a better picture than relying on just accuracy in machine learning tasks. And in this case now, in the machine learning task that involves customer churn. So yeah, moving from this now, once I've gotten my randomized search CV, I'll fit my model again. I predict on the test set, get my model evaluation, and then I run it now. So you can see that now that I implemented randomized search CV, so it was able to get the best parameters for these models. N estimator 50, sample split 2, minimum sample leaf 4, max depth 10. and you can see the accuracy is 0.6267. Now, what was the accuracy when there was no hyperparameter optimization? So this was the accuracy, 0.6725. You can see even the accuracy metric of random forest when there was no hyperparameter optimization dropped after I implemented hyperparameter optimization. And then the recall and the F1 score metrics, they both dropped and improved. So for customers that did not churn, initially the F1 score was just 0.80. For customers that churn 0.115. So after I implement hyperparameter optimization, you can see that customers that did not churn 0.75, customers that did churn 0.25. You can see how with hyperparameter optimization now, the model metrics are now giving a clearer picture of what was needed. So now looking at logistic regression, it was able to randomize RC was able to get the best parameters, classifier solver, leave linear, penalty, L1 penalty, and then the classifier C. And then you can see even the accuracy score dropped. And this just XGBoost. These are just warnings. So for XGBoost classifier, these are the best parameters for XGBoost classifier. You can see even XGBoost accuracy, the accuracy score also dropped to 0.6030. I have my F1 score, I have my recall, I have my precision. So now understanding the evaluation metrics. Now, accuracy is the proportion of correctly classified instances, both churn and not churn, and it can be misleading on imbalanced datasets, as a model might get a high accuracy by correctly predicting the majority class while not detecting the minority class. So when you have issues like this, when your dataset is dealt with a huge percentage of class imbalance, and then precision, what precision means in this case that of all the instances that the model predicted to churn, what percentage actually churn. So high precision means that there are fewer false positive. Now, if fewer false positive means fewer cases where the model predicts churn when the customer didn't churn. Now let's look at recall. Recall is also known as sensitivity. Now recall in this data set, in this task means that of all the customers that churn, what percentage did the model correctly identify? Now, a high recall means that there are fewer false negatives, and fewer false negative in this case means that there are fewer cases where the model missed identifying a churner. And F1 score, which is our harmonic mean, is the harmonic mean of precision and recall. So this metric is a balanced measure that combines the effect of precision and recall metric. So when you have an imbalanced data set, F1 score is generally more useful than accuracy. That's why in my hyperparameter optimization, I decided to use my scoring to be F1 and not accuracy. So moving from this now, let's talk about the next metric, support. Now, support means the number of actual occurrences of each class in the test set. Now, recall is important in churn because in churn detection, you need to identify which customers, the customers that churned, high recall to prevent the any occurrences of having a churn again. And another thing is that it's generally more costly to miss a customer than to incorrectly identify a customer. So you need to decide on a model that gives you a higher recall at the expense of some precision. So let's look at our model metrics after I was done with the hyperparameter optimization. So the random forest model exhibited a recall of 0.22 for the churn class, and this means that it's correctly identified 22% of true positive instances. Now, for each precision for the churn class was measured as 0.30, suggesting that 30% of instances predicted as churn were indeed true churners. So that true churners, like indeed customers that actually churned. And this resulted in an F1 score of 0.25 for the churn class, which indicates a moderate harmonic mean of precision and recall for this class. So the interpretation of the random forest model performance is that it exhibits a modest capability in identifying churners, demonstrating an expected trade-off between recall and precision. Now let's talk about logistic regression. Logistic regression model had a recall of 0.55 for the churn class. That is, it classified that there were 55% of the true positive instances. And the precision of the churn class was 0.29, indicating that only 29% of predicted churners actually churned. And we have the F1 score. So the interpretation is that why this logistic regression model achieved a higher recall, this is accompanied by a notable decrease in precision. You can see 55% metrics attached to the recall, but precision was 0.29, 29%. Now let's look at XGBoost classifier. XGBoost model achieved a recall of 0.28 for the churn class. That is, it identified 28% of customers that actually churned. Then for precision, precision was 0.30, which means that 30% of those customers that that it predicted to churn were actually customers that churned. The F1 score of 0.29 for the churn class shows a better balance of precision and recall compared to the other two models. So what does this? The interpretation of this means that XGBoost classifier model demonstrated a higher capability in detecting churners in comparison to the other models while having an acceptable level of precision. So let's look at comparative analysis, minority class focus. Now, to facilitate a focused comparison between the minority class, the models were ranked based on their following metrics. We have the recall. You have recall of 0.55, edge boost 0.28, random forest 0.22, precision of 0.30 for random forest, 0.20 for edge boost, 0.29 for logistic regression. F1 scores, we have our F1 score of logistic as 0.28, edge boost 0.29, random forest 0.25. Now, model selection and recommendations. So, given the priority in identification of churners, because the major goal of this task is building a machine learning model that can predict which customers did churn or not. So because of that, because of the main goal of this task, the XGBoost classifier model was now deemed as the most performant model in the evaluation. Now the rationale for this selection is threefold. Superior recall. The logistic regression showed that it has a higher recall compared to the rest, indicating its higher proficiency in capturing this. And then so this is meant to be logistic regression model is deemed the most performant. So recommendations for further research. It's recommended to adopt the logistic regression classifier as a true baseline for churn prediction based on the metrics provided. So now that I've selected my best model, which is the logistic regression model, now I want to like train this model again and get another performance. So I'm just going to put it again through this pipeline. Start training again. I'm getting my metrics back. Start getting these metrics and I save my model. To save your models, after you're done training your models, just like there's this popular saying, don't end or don't stop at Jupyter Notebook. Because let's say if you're working in a company and you're the machine learning engineer or machine learning researcher, if you just stop at your Jupyter Notebook, the guys in production won't carry your Jupyter Notebook and feed it to the product they are building. So you have to save your models, and those models you're going to save, once you save your models, you can now be able to export those models to the backend framework. So if you're using a Django framework, Fast API, Flask, Golang, Java, as long as you've saved your machine learning model, you can now use those models in your backend framework, and with this you can work into production. So let's now talk about the next. So now that I'm done saving my models, so yeah, I saved my min-max scalar model, I saved my logistic regression model. So this is the backend, and this is a Flask. This is a Flask backend. So this backend deals with the model that I saved and exported. So you can see this is just initializing the Flask app using an SQLite database. So these are the columns, the important features from this model that I trained, and then this just course configuration. I have my numerical features, I have my label encoded. Then this is just a pedantic class for validation, loading the model and the scalar. So the model is the logistic regression model. The scalar is a min-max scalar. And then once I'm done, this just this. And this is the endpoint for model predictions. Does anyone have any questions so far? Hello. Does anyone have any question?
Hi, good evening.
Yes. Yes. Can
Hello.
you hear me? Yes, I can hear you.
Hi. Thank you so much. The class has been enlightening. So I missed that part where you said your model shouldn't end in Jupyter Notebook. Now, I want to ask this next step, is it you deploying it or making it something that a regular user can access? Like this next step.
Yes. 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 That is next step. Upon training your model, you
Okay.
have evaluated your model performance. Once you've done that, you have to export your model. That's why I say don't end in Jupyter. You export your model, and When you're done exporting your model, you now use that model in a backend framework. So in this case, now what I
The
used was
backend what?
Flask, a Python Flask backend framework to work with the model. So if you look at this now, this line of code deals with loading the model that I trained, which is the logistic regression model, and whatever prediction that is going to be done on the whatever prediction that is going to be done here is going to work with the logistic regression model that I trained. So this is like the back end. So do you understand it now?
Oh, yes. Thank you.
Okay, okay. Another thing is this: if you want to export your model or save your model, you can use JobLib, which is a Python package for saving and exporting your models, or you can use Pico. So if you use JobLib or Pico, you have to use it for both exporting and loading your models. Like exporting your models from the Jupyter notebook and loading that model which you exported and saved to your backend framework. So if you look at this now, I use Pico to load the model which I saved, which is the logistic regression model. So that's what I did here. So is that clear? Does anyone have any
Yes.
question?
Thank you.
Okay. So yeah, now this is the final work of everything that was done. So you can see this is the front end. So basically, you just want to test it. This is the front end of what was done, and it deals with just this. So if you fill in your details here, I'm just filling random values here now. So, so I use just 2 minutes of 5. So this customer service ratio. So 39, sorry, 1. Retention cost, number of course, retention departments. So 5. Not retention offers accepted. 0. Wage cut retention team 0. I didn't make any call. Total revenue generated, say 5,000. Monthly revenue 200. Total recurring charge, say 200. Just want to pay the rating. So it's and then months in service, duration in service. Let's just look at 13 months, possible change in minute. Change revenues, just change revenue had like 20%. Handset price, that is cost of equipment, 5,000 modem, say 5,000. Customer credit rating, customer credit score. So let's say this customer credit score by 2. Income group, say 5. Age of primary account holder, let's just say 15. Secondary account holder, if applicable, 36. How many children in the household? Let's just say 5. So once done, prediction. So yeah, it's just processing. It's taking longer than expected. Let's check. So, so I just need to do this again. Yeah, it's taking longer than expected. So, So you can see this now. Can you see this? Hello. Can anyone see my screen?
Yes, we can.
Yeah,
Yeah.
we can see.
So you can see now this the model was able to predict 99.9% chance or probability that this customer is going to churn, so high risks of churn, and then critical retention actions required. This is just like action plan for the ISP, internet service provider, that they can implement, just suggestions of what they can implement. So you can see how I was able to move this model from just the initial Jupyter notebook to a backend. I was able to train the model, then export it as a SAV file, and then load the SAV into my backend, which is this Slack's backend, and link everything up to my React front end. So yeah, is this clear to everyone? Any other questions so far? Any other questions? Hello, does anyone have any question to ask?
All right. I don't think there's any other questions. So can anybody have says one? So, Matoya.
Yeah. Yeah, I can hear you.
Hello, I have a question, please.
Oh, okay. Go on.
Yeah. So, um, after deploying the model, so I want to ask, does it handle new data? Like, okay, let's say the
Yes,
data set gets updated over time.
yes, it handles new data. Yes.
Okay, okay.
Okay. Any other question?
I
Okay.
don't think there's any other question. I don't think anybody wants to ask question. Okay. Mr. Mr. Ibuka, are you here? Are you still here?
Yes, yes, yes. I'm here. I'm here.
Oh, okay. I don't think anybody has question, so you can continue.
Okay. Yeah, we are
Oh,
done.
oh, okay.
We are done.
Okay, so in the midst of no question, I guess we have come to the end of this section. Okay. So thank you very much, Mr. Ibuka, and
Okay.
for
Thank
every
you.
other person that, yeah, that participated in this program. It's been a wonderful weekend because we started the code workshop on Friday. We had Mr. Ayo on Friday, we had Amber yesterday, and today we have Mr. Ebuka. So thank you for staying with us for these 3 days, this code workshop. And okay, Mr. Ebuka, somebody is asking a question if the data set is available for us to experiment. Mr. Ebuka, are you there?
Yes, yes, yes. The data set is available. So I'll just share this GitHub repo link. The data set is here. This CSV data set. So this is the data set.
Okay. So he's going to share it. Once it's gets across to me, I'm going to share it on the open source group. Like I'm going to. Okay. So thank you very much. We have come to the end of the section. I hope you learned a lot, and have a good night, everyone. Bye.
Yeah, thank you, everyone.
Bye bye.